Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The acidity of ACH bond in hydrocarbons depends on the stability of the conjugate base, carbanion, formed after deprotonation. Greater stability of the carbanion means stronger acid. Moving on to the next step. Identify the acidic proton in each molecule. A. Benzene, sp to CH bonds, deprotonation gives a phenyl anion, which is not specially stabilized by aromaticity of the ring. B. 1,2 dihydronaphthalene contains sp3CH2 groups at C1 and C2. Deprotonation gives an allylic benzylic carbanion stabilized by conjugation with the aromatic ring and the adjacent double bond. C. Indene contains one sp3CH2 group at C1. The methylene bridging the 5-membered ring. Deprotonation gives the indenyl anion. The 5-membered ring then becomes a cyclopentadenyl type anion fused to a benzene ring. This anion is aromatic, 6 pi electrons in the 5-membered ring. The lone pair on the carbanion carbon plus 2 double bonds is equal to 6 pi electrons, satisfying Huckel's rule, 4n plus 2 with n is equal to 1. Aromatization of the anion provides exceptional stabilization. D. Benzosuberene, benzene fused to a 7-membered ring with one sp3CH2. Deprotonation gives a carbanion in the 7-membered ring. If it became aromatic, it would need 8 pi electrons, anti-aromatic for the 7-membered ring, so no aromatic stabilization is gained. Moving on to the next step. Compare stabilities. Option C. Indene. Upon deprotonation at the sp3CH2, the resulting anion is isoelectronic with the cyclopentadenyl anion, a classic 6 pi electron aromatic system, fused to a benzene ring. This gives exceptional aromatic stabilization to the conjugate base, making indene by far the most acidic of the 4 hydrocarbons, pK-20 versus 43 for typical sp3CH. Options A, B, D do not produce an aromatic anion upon deprotonation, so their conjugate bases are far less stable. And for the final step, why other options fail? A. Benzene anion, no special aromatic stabilization of the carbanion. B. Allylic benzylic anion, resonance stabilized but not aromatic, much less stable than the indenyl anion. D. 7-membered ring carbanion would be anti-aromatic or non-aromatic, destabilized or not specially stabilized. Therefore, the correct answer is C. Therefore, the correct answer is option C.